My name is Alexia Gorman, and today I'm going to be talking about my 2023 surf experience here at the University of Florida. A little bit about me is that I am from St. Mary's County, Maryland, and I go to school at West Virginia University, where I am a biomedical engineering student. I've done research for about a year and a half now, and I am going to be graduating in May of 2024. This summer, I worked at the Department of Biomedical Engineering under Dr. Carlos Rinaldi Ramos. He is a leading scientist in the areas of ferrohydrodynamics, biomedical applications of magnetic nanoparticles, and the transport of nanoparticles in complex and biological fluids. My graduate mentor this summer was Bo Yu, and I was able to work alongside REU student Nais Cruz Delgado. My project this summer was to analyze the effect of macrophage uptake based on polarization through magnetic particle imaging, also known as MPI. To start, I'm going to give a little background into each of the components that help make up this project. Macrophages are a type of white blood cell that play a major role in the immune system. They are involved in detection, phagocytosis, and destruction of bacteria or other harmful organisms. The interesting thing about macrophages are they are part of the adaptive and innate immune system, which is due to their ability to polarize. Macrophage polarization separates macrophages into different categories based on the response that it has due to its environment. The two main kinds are M1 and M2. However, there are subsets of the two. The main focus was looking solely at M1 and M2. M1 polarization is pro-inflammatory and can kill microbes, whereas M2 is anti-inflammatory, which helps with tissue repair. The particles that were used for this study are an optimized MPI tracer, RL1, coated with polymaleic anhydride alt-1 octadecene, or PMAO, conjugated with a fluorophore. These particles are made within the lab by other lab members, and this summer I was able to use a batch for my project. The main imaging technique was MPI, which is a non-invasive tomographic technique that directly detects superparamagnetic nanoparticle tracers. For the experiment process, I used a macrophage cell line called RAW 264.7, where I first administered various particle concentrations from 0 to 50 micrograms per milliliter. From this, I found that 25 micrograms per milliliter gave us a high uptake of nanoparticles with a higher cell viability. From here, we looked at confocal to confirm the internalization of the nanoparticles in the macrophages. This is where we decided to introduce polarization of the macrophages to see if there would be an effect on the uptake of particles. To activate or polarize the particles, we added LPS to polarize towards M1 and IL-4 to polarize towards M2. Both of these activators were chosen from information found in the literature, along with the amounts administered. LPS is an outer membrane component of gram-negative bacteria that triggers the secretion of many cytokines in macrophages. IL-4 plays an important role in adaptive immunity, including the stimulation of activated B cell and T cell proliferation, which can help fight disease. Given the time frame of this internship, we could not confirm polarization, so we'll simply be looking at how LPS and IL-4 affected the macrophage uptake versus polarization. From here, we dose the cells with 25 micrograms per milliliter of the particles and analyze the uptake difference between 4-hour and 24-hour time points of particle exposure. So here are the images from confocal. The green dots represent the particles within the cell where we were able to confirm the particle internalization. The image on the left is an example of the MPI scan that we analyzed, which shows 3 samples, and with this, we measure the intensity of the signal taken from the brightest portions of the dots and are able to get an idea of the amount of particles taken up by each cell. In the 4-hour study, you can see the IL-4 did have slightly better uptake, but still was not significantly better than the unstimulated or LPS-stimulated macrophages. The 24-hour time point, however, was slightly different, as it is shown that the unstimulated had quite a bit better intake than both the LPS and IL-4 stimulation. As stated before, we did not confirm polarization, so we can only see that per the amounts of each used of the IL-4 and LPS, there was not a significant difference amongst them. However, there was a difference shown with the unstimulated in the 24 hours. There's also a bit of variation in the standard deviation shown in the results, which were very inconsistent, leading for much more room to further look into the causes behind these occurrences and further research. Overall, this summer has not only been a fun experience of learning, but also a great time getting to live and explore Gainesville. It has been so much fun having the opportunity to see the campus and all that UF has to offer, from great food to live music and all the beautiful nature that surrounds. However, you do have to enjoy at your own risk of being downpoured on just about every day. And trust me, after the first time you forget your umbrella, you will not do it again. But all jokes aside, I do want to give a big thanks to not only my graduate mentor, Bo, and my professor, Dr. Rinaldi, for this summer and helping me grow in research, but also everyone who helped in the CERT program to bring us here and allow us the opportunity. It truly has been a great experience, and I'm very thankful and appreciative for it.